Awesome. Over to you, Justin.
Excellent. Well, yeah, good to be here. Thanks for the intro. Well, yeah, so 5 year, yeah, I'm going to talk about 5 year perspective. This is kind of weird kind of thing in container security because it feels like an awful long time. I'm give you a bit of an intro to me if you don't know me. I'm an engineer at Docker. I'm in the Cambridge, UK office insofar as anyone has any offices anymore. I'm also on the CNCF's Technical Oversight Committee. I work for Docker, and Docker is a company that loves developers. We kind of split away from the bit that we sell to Mirantis, the enterprise product, and we're really developing developer products now. I've worked on security, open source. I work on partnerships and collaborations, and I work really across the whole of everything we do at Docker, which is good fun. I'm Justin Cormack on all the social medias and everything. This is Cambridge. If you don't know Cambridge, if you follow me on Twitter, I wander around this part of Cambridge a bit. I like Cambridge because it's a sort of tech village. This is radio telescopes we have just down around the corner. It's a sort of, it's a tiny little place, but we do a lot of tech here. 5 years. Whenever I say 5 years, I always remember the Bowie song. But it's weird because 5 years ago, I was living on the rainy streets of London, and I started getting involved in container security. I actually worked on a chapter of a book on Docker security back then, and by some kind of interesting path, I actually ended up shortly after that actually working at Docker, where I've been since then, and I've been working on security kind of all through that time. And it's a lot happens in 5 years, and kind of a lot stays the same. And sometimes it feels a long time, and sometimes it feels a short time. Sometimes it feels we've achieved loads, and sometimes it feels like we've hardly got anywhere. And so I want to reflect on these things in this talk. Particularly, things change and things don't change. I put a few French quotes in here because I work with a lot of French people at Docker. So Docker's always been a very half French company. The most asked question about container security in the whole of 5 years. I mean, I did a Google search when I was doing these slides, and you type containers versus, and virtual machines is the top of there. There's some other things, but it's like there's this kind of weird thing that we've become very, very confrontational in how we talk about things in software, which is kind of really bad. And I know that we've seen the rise of confrontational politics and things in the last 5 years as well. It's stop doing that with software. There's value in all these things, but this question is actually interesting because it's been like the number one question throughout this period. It's something that right at the beginning everyone was totally obsessed with because virtual machines were really the point of comparison with containers. What is a container? It's like a virtual machine, but actually the great thing is in the 5 years, this actually is something we've totally and utterly solved. And I can now tell you the answer to this question, which is great, because then people can stop answering it and I'll never have to answer it again. So suspense, we know all the answers. Containers, one, the developer experience. Absolutely everywhere you go, developers are using containers, developers love Docker. We're a developer experience company now, as I said. Containers are everywhere that developers are. If you look even on the other side of things from the VMware, that classic infrastructure company, they've really pivoted to a container company. They're shipping containers alongside their VMs. Kubernetes has risen up in the last 5 years to be absolutely everywhere. Everyone is using Kubernetes. It's an enormously successful project. Everywhere, containers have totally won, and people talk about containers all the time. People don't talk about VMs all the time. And containers want innovation. This is the CNCF landscape. Everyone kind of likes to laugh at the fact that it's kind of, there's so many things on it, you can't even see what they all are, and they get increasingly small every time it's revised. But if you think about it, this is a measure of the amount of innovation there has been in the container space. Pretty much none of these things existed 5 years ago, or if you looked at it, probably have maybe 4 or 5. I don't know, maybe there's more like 10. Whereas the container space has brought all this enormous amount of innovation, and this innovation has been really exciting. It's meant that we've been able to deliver software much faster and better, and more securely. And like this has been a gigantic amount of innovation just led by containers. So that's kind of containers for totally eclipsed the VM from that point of view. But this is a security conference. Let's talk about the question, because actually the containers versus VMs was often kind of implicitly really a security question, not a UX question to a lot of people. And here we've also actually got the answer, really, which is that fundamentally we've given up on Linux being a secure multi-tenant OS. And what I mean by that is that there are no commercial services where people sell hosting of you can run a container on here on the same machine as other people can run a container on, and you'll still be securely isolated. There are, containers can't do something if Linux can't. And although there haven't been a lot of them, there have been a bunch of exploits where if you've got user space access on Linux, like inside a container or inside an application, just inside a process, and you've exploited it, you can compromise the Linux kernel. Once you've compromised the Linux kernel, you can compromise every other process on the machine. And that's just, there have not been a lot of these, but they do turn up regularly, and there's no evidence that they're going to stop happening. And there's a general view that you need 2 independent security layers for safe isolation. This is a kind of a hard requirement at Google, for example, but in many other places as well. 2 security layers to stop someone getting out. And with the Linux kernel API, you've got 1 security layer, and then you can't really protect it any further. And containers are just Linux, remember, to a large extent. I mean, if Linux can't protect your application, then the container can't. I say no one sells a general multi-purpose multi-tenant hosting platform just based on Linux namespaces. I mean, there are still just about web hosting providers selling Linux, but these are kind of very these used to be a big thing, and they're now a very small area of the market, and no one would argue that they're actually secure enough for a lot of use cases. For most people, this doesn't necessarily matter, though. When it does matter, where it generally has been where you get this combination of VMs with container APIs, these kind of solve the container VM problem in a different way. So if you look at services like Amazon ACI and AWS Fargate, these are just little tiny lightweight VMs that are running containers and provide a container type API. You say, I want to run a container. Kata Containers is an open source project to do the same thing. And you can run that as part of Kubernetes. The virtual kubelet project really is a kind of driver to drive these types of container VM hybrids. A few weeks ago, we announced this collaboration with Microsoft to bring the kind of Docker CLI to the Azure container instances. So this will just mean you get the full Docker experience. You can do Docker run, you can do Docker compose up, but just not against the Linux kernels and against the Docker API, but against the directly against the Azure API, which means that we're kind of taking the Docker experience and making it work more broadly. You can build things. You can build this yourself with kind of Kata containers if you want to do, because Kata containers is kind of OCI compatible, so it looks like a normal container as well. And so this kind of crossover has been the answer from the security and usability point of view to basically bring these things together. But in practice, isolation's kind of actually for most use cases where you're not running a commercial multi-tenant service, we've actually in the last 5 years only had maybe 3 real 0-day container breakout escapes. I think it's 2 or 3. It's a very small number. Container escapes are far more likely to be due to misconfiguration than actually a bug in the containers. Containers also provide better isolation than not using a container, which is really the alternative for a lot of people. People is not run every process in a VM. It's run run lots of processes together or run them in a container. And container is better than nothing because it provides some isolation. And much of the conversation about the sort of hardened isolation, like multi-tenancy and things, is not really, it's a bit divorced from user concerns because most users are not running a hard multi-tenant infrastructure running untrusted code from multiple users. That's not it's not the use case for the majority of people. So often these questions are kind of not the important question. That's one of the things that you've noticed about these 5 years, is that we spent a lot of time talking about things that for a lot of people actually aren't the key things that that really matter. I want to talk about the future of this a bit, having answered the question about containers versus VMs, like what's going on in this space, because it's like secure isolation is just a fascinating area in the last 5 years. We've had Spectrum meltdown and other side channel attacks on hardware, which have actually really changed the kind of security landscape in terms of what's going on. So far, these things have been fixed, but at high cost in terms of performance. We're talking about security patches with these things that, depending on your workload, might be 10% worse or 20% worse. There's some discussion about patches the other day about things being 50% worse. I mean, these are real problems with side channel attacks, and potentially this threatens like the isolation of VMs. So far we've been okay, but I'll talk about this a little bit more later, but I mean, like, are we going to go back to bare metal? Are we going to have more layers of isolation even on VMs? This is kind of putting things at risk in terms of the way we expect things to be isolated in VMs now. But then despite all this, software isolation is coming back. We've had browsers running untrusted JavaScript code for the last 5 years, and it's been generally pretty secure. It's been one of the most attacked areas there is, and yet there haven't been, it's proved to be relatively robust. I mean, there have been some exploits, but as a security in practice model, given that it's the most attacked the most attacked form of isolation there is, it's done pretty well. So a lot of people have started saying, well, despite things like the side channel attacks, actually software isolation is kind of exciting. And things like Cloudflare Workers and Fastly and people have been doing really exciting work on this. They've reduced the API surface drastically to reduce the attack surface. So Cloudflare doesn't provide accurate clocks to make timing attacks much more difficult and things like that. So there's kind of API limitations, but and then there's constant vigilance in terms of making sure that things are not being, monitoring attacks. And then there's interesting projects like gvisor, which reimplements APIs in Go code in user space as a more secure way of doing it. So there's some really interesting work going on isolation that will affect the container space over time. If you look at the amount of work that players like Amazon are doing, if you look at what seems to be going on with Lambda and Fargate, they're doing the multi-layered thing. So there's you don't get root access on Lambda, and you get, even on Fargate, you get very restricted root without like access admin and other capabilities. You don't get to choose your kernel and access that. The VM's wrapped in Firecracker, which is highly written in Rust to avoid all the issues that QEMU's had in the past with emulation. It's very minimal and very sandboxed itself. And then it's running on a lockdown host. So they're taking the view that with enough layers, these services can continue running even if there are more exploits. The cheap answer for multi-tenancy is just stick to things on different machines, and that's going to become, I think, more of a strategy for people over the long run. Run containers on bare metal with related workloads that you don't need to protect from each other. So in the second part, really, I want to talk about developer-focused security, because I think that's one of the things that we made a lot of mistakes around. As I said, the question of containers versus VMs is not really so much a developer question. Developers have already chosen containers largely. And we've had this kind of thing in the security industry that's kind of, fear sells. We should sell security by fear. And I think that's been a real kind of negative, and we should be working with developers to sell them things, that they actually want to use. And this is a DevSecOps conference, and I think this is what DevSecOps is fundamentally about, is about bringing people together to do things they want to do better. And developers often don't care about security, but I think another thing that happened in the last 5 years that's really significant is Let's Encrypt. So Let's Encrypt did two things. One is there was an incentive to implement it because Google basically said your SEO will be worse if you don't have HTTPS, and that was the stick. And then the kind of carrot was it was very, very easy. It was automated. Like there was thousands of scripts and services to set it up. And it, we've gone from TLS being fairly rare and difficult and annoying to maintain to being pretty universal. It's not 100% universal, but it's a massive change in a couple of years. And it's really important that we make things easy to developers, because if developers have to choose, they'll choose the insecure default option. Even if it's documented insecure, even if they have to write --, really, I want to do this thing. This is a terrible idea on the flags and the config, they'll still do it. Because if it's easy, and if the secure thing is difficult. And there's been a bunch of examples in the last 5 years. One of the things that still find out sometimes is that, people are running Docker exposed to the internet without any authentication at all, so that you can just, it's just the Docker socket is there, your host, you're giving someone root access to your host. And there's not a lot of these hosts, but they've all been compromised already probably, but it's just really, really difficult. And the setup you were supposed to do when we introduced, remote Docker sockets, we were supposed to set up mutual TLS. But mutual TLS is really hard for people to understand, set up, and use. I would say generally, don't use mutual TLS in a service that people are supposed to use. If it's for computer-to-computer services, it can be made to work, and lots of service meshes actually help automate that for service-to-service things. But for things that humans have to access, it's a really, really bad idea. We eventually, in Docker, we added support to connect to tunnel over SSH to a remote machine, which is probably what we should have done in the first place as the only option. It's still, not everyone knows that it exists because it's only been around for 2 years, and people take a long time, and there's old documents and blog posts and things that tell people what to do. And people hear about things and use things and set things up in insecure ways that they've heard. The best thing is never to add the insecure options in the first place, because our experience has just been that migrating people away from using these things is just really, really slow, and kind of it's difficult. Another thing, I'm going to talk more about Notary and image signatures before, but again, we made it opt-in, and not very many people have opted into it. And so Notary v2, we're working trying to fix this, but the original design we did for signing actually signed all images, had another problem that it was actually hard to know who would actually sign the image because there wasn't a very good key distribution mechanism. But it was opt-in, and that was in many ways a kind of better design, although arguably it was just confusing because you didn't know what the keys were anyway. But so it was in some ways half a design, and we're spending a lot of time discussing these issues with Notary Veto at the moment. I'll talk about that in a minute. But again, like opt-in, if you make something opt-in that's a security feature, people will just choose not to opt in, and very few people will opt in. You just have to turn it on. Things I'm really not sure about that we did. Me and Jesse Frizzell worked on the Docker seccomp policy years ago. Is one of the first things I did at Docker, and I'm coming around to the view that actually I'm not sure how useful it is anymore. To some extent, we started using it to reduce the Linux kernel attack surface by doing things in Docker. And I don't know that that's the right place to do that. And to some extent, a lot of that has got better anyway. A lot of Linux distributions have tightened up their kernel security settings back since then. So things are a bit better than they used to be. There's a performance impact that, although not everyone notices it, is actually problematic for some applications if you do a lot of syscalls. And seccomp was actually designed for programs to do their own security config rather than for it to be set by system administrators. And that we were trying to basically do that as a kind of global policy. It's really hard to use, and so the rationale we had was that we could because it was really hard to apply seccomp policy. Almost no applications had their own seccomp policy, so it was kind of better if we provided one that did at least something. But it's kind of minimal what it can do, and it's not clear that it's really worth it. There are huge numbers of issues with seccomp, and there's actually some people working on actually improving it at this point, so maybe it'll get a little bit better. But it's got all sorts of problems, like every time the syscalls that your operating system uses change, you have to change your policies, and that turns out to happen like regularly. At one point, we broke our seccomp policy in Docker, broke Steam, and so we were really unpopular because it turns out a lot of people run Steam in Docker. It's been a lot of a burden, and I'm really not sure about the cost benefit analysis on this anymore. Things that I am more happy about that we've done in the last 5 years. I think we did generally choose the right default security for Docker, with the exception of this whole thing about CapNet Raw. I did a talk with Liz Rice at DockerCon just a few weeks ago called Lack of Self-Isolation, where we talked about the fact that we gave containers more capabilities than they should really have had, and which has caused some vulnerabilities. But we did it because we wanted people to be able to use ping. And over the years, there's some ways that Linux distros have managed to work around the fact that ping requires CapNet Raw. So I think we can actually fix this. But apart from that, generally we did choose good defaults. For some years, Jesse Frizzell maintained this Docker security non-events page, which said all the things that Docker had protected against. These, again, were some of the things that the seccomp policy did block, but there were also a bunch of things that we couldn't block with seccomp, and due to the complexity. And some of it was due to user namespaces, which is just the one kind of area that really did increase the attack surface. But again, some Linux distros let you just turn that off, and there's other, but it's useful. I mean, it's like we've kind of ruled out people using user namespaces for good things by trying to reduce the attack surface. So I'm a bit ambivalent about that. And then the other thing I'm happy about, all the major security issues in the ecosystem were disclosed responsibly. And as far as I know, no one actually got attacked by these things. They were pretty obscure generally. And the community's been quite good at working together on security issues across different companies and things like that, which is great. Another thing I really want to talk about, because it's really, I think it's been a huge force for change, and it's really just starting, is the CNCF6 Security. This was originally the SAFE working group, Secure Access for Everyone, in 2018, and became an official security working group, and in particular became a community of people who are interested in cloud native security. And I've been involved for a long time, and I think it's incredibly valuable. And I think the biggest thing I've seen coming out of this, and really in the last couple of years, is that end users who are like using Kubernetes and using cloud native software are coming out and starting to share and open source the tools they use and the way they think about things and the security issues they've been having. And this is still a new thing, but it's absolutely the best way to actually progress the ecosystem and involve everyone together. Security driven by what the users, the real problems real users are having in production is incredibly valuable in this community. And also, security has a cool trash panda logo, which is very important. So come along and join. Looking forward, those kind of trends of cooperation and security, I think, is the thing that has changed most. I think we're working together an awful lot more than we were 5 years ago, and I think that's incredibly valuable. And the Notary V2 I talked about a little bit before. Late last year, we kicked off Notary V2. So Notary, if you don't know, is a project for signing container images, so that if you want to know where they came from, who built them, and make sure that they're actually the right container image that you wanted, and that they've it's a project for adding cryptographic signatures to them. And we started working on V2 because of a bunch of issues with V1, but this from the beginning was a joint project between Docker, Amazon, and Azure in particular, but also the update framework team, who are largely based at NYU and elsewhere, and Red Hat, and there's actually a bunch of other vendors and other people in the ecosystem as well. JFrog and people have been involved. So it's a really community effort from day one to work on a single solution that works for everyone's customer needs. That's meant that it's taking time, because it's sometimes it feels different. There's lots of different requirements and needs, and we have to work together. But the important thing is that we'll get a consensus of what everyone wants. It's something that everyone gets behind at the end, which and everyone will support. Currently, not all registries support signatures at all. The signatures are not portable between registries, which is really important. So we want it so that you can sign an image, and then that the information in that signature can be transferred elsewhere, so that it's a single supply chain, regardless of how you actually use registries on your way production. Security is difficult, and working together just makes it easier, I think. And we've had an awful lot of input, and sometimes it feels like it's taking a long time, but it's also just coming up with something and trying to impose it on people is not the way we're going to get something secure. It takes time to look at the security and work out what whether your threat model is whether this particular thing solves your threat model, what the issues are, what the bugs are, all those kinds of things. Another thing which we're doing in very developer-focused security is Sneakin Docker working together. We announced a few weeks ago that we're doing a joint solution for scanning, security CVE scanning on Docker Desktop and Docker Hub. We really want to make scanning more widespread and easily available. There are millions of users on Docker Desktop, and all of them are going to have access to security scanning. And this is, and we'll go forward, and this is a program that we're going to go forward and make it easier for developers to understand and use scanning together. And we want to help people act on security issues easily. It's something that you don't want it just to be information overload. You really want it to have focused, this is what you need to do. And we're really pleased to be working with Snake. We don't want to this is something that you need a specialist like Sneak who's in the scanning business, and then we're really interested in making the UX better and helping our users actually use scanning effectively, and that's really good. And I think that going forward, the thing that it's been really exciting watching these projects in the CNCF that have been security projects such as Spiffy and Azure Open Policy Agent, TAR, Fargo, and things. These are open source security projects that are starting to see real momentum and real users. And those historically, open source and security were often, despite everything, not things that went together very well. And it's nice to see that security companies like Aqua, for example, have an open source team now doing open source projects. Liz is working on that. That's really great to see. I think that there's going to be a lot more open source in security, and a lot of it's going to be driven by end users, which is going to be really exciting, and I'm really excited to see that. Developer experience is really important, and security has to be there, by default. It's not as an add-on. It's got to be turned on from the beginning. So it's been an exciting 5 years. I mean, DevSecOps is something that the word has been around for a while, but I don't know. It's funny, when DevOps happened, I was like, oh, yes, this makes sense to me. I've been a dev person and an ops person in my time. I used to do ops before I did development full time. And then I kind of moved into security as later. I think security is not, these are things that you shouldn't just be in one of those buckets all the time. Security is hard, and therefore people sit in the security bucket. And it's really important to have deep specialists on things, because there are really deep and interesting problems in security that are just very, very difficult, and people can make mistakes very easily. And there's people who are good at taking very specialist things and turning them to things that are harder to make mistakes, which is a really valuable specialism too. But I think everyone should spend some time working in security, and I hope people spend some time in container security. There's a huge field of container security, and I think that you can spend a little time becoming an expert in an area of container security, and it's really, really valuable. And spend time working with security people, understanding how they think and understanding how to talk to them is valuable. I think CNCF6 Security is a good place if you want to find some people and see what they're talking about and what they're interested in. We've still got to work really hard on making security usable and pervasive and always on, and it's a really hard problem, and it's we can definitely spend the next 5 years doing that. It'll be an incredibly valuable thing to do, and I think that that's the way to approach it is to spend time with users, spend time with developers, and find their concerns, and just make things easy, because hard things are just hard, and we can't all be experts in everything. And if you have to be a security expert on everything, it would be really hard to ship things at all. But so we need to package things up. Think of the Let's Encrypt model. This is a hard thing packaged to make it easy, and those are the kinds of things that we need to achieve more of in container security, really. So thanks very much, and happy to take questions here. And it's been really great presenting to you. This online conference thing is quite good fun, really. So I hope you enjoy the rest of the day.
How do you find the online? Well, first of all, thank you very much, Justin. It's an awesome presentation. How do you find the online conferencing then compared to say virtual, physical? Because obviously you can't see the audience, right? So
yeah, I know the not seeing the audience is actually kind of weird. I actually meant to set up the online chat so I could see it out of the corner of my eye, but it's actually you can't concentrate on it. So it's just, right. But it's kind of, it'd be nice to just sort of have it just so you can see there really are people there. I don't know that, because that's the weirdest thing, is just talking to this talking, just talking with, and you can't see anyone. I mean, in a sense, when you get in the flow, it's not that different from being at a conference, because you don't really, I mean, you mostly don't answer questions during the talk. Well, sometimes I do, but you generally just have a sort of sense of the audience there. But it's just, but when you get in the flow, it's fine. But it's just that sort of lack of feedback is a bit weird.
For sure. Right, we've got a couple of questions here for you, Justin. First one coming in from Alice. Can we trace our containers with eBPF to create a seccomp profile for our containers?
Yes, you can. Yeah, absolutely. You don't actually need to use eBPF. There are some logging modes for seccomp, and you can do it with the audit, but the eBPF is a kind of nice way of doing it. And the eBPF tooling is getting way better now. So that's one way of doing it. You have to be a little bit careful, and this is a lot of people, is that will work, but it'll tell you what syscalls it is using in your current environment. And then the problem is if you change things, it might change. So for example, there's been a bunch of cases where syscalls have changed quite a lot over the last 5 years. There was the first one, I think, that broke a bunch of seccomp profiles was when libc changed from using open to openat. Openat was originally a syscall that added a directory thing to open, but it also added more flags, and it basically it became the best way, the modern way of doing it. And the open syscall was marked as kind of legacy, and it was the cross-platform thing. So that was switched. So all the syscalls then they switched from open to openat, and if you didn't have them both in your seccomp policy, when you did that upgrade, all opens would fail, and that was kind of inconvenient. We've had a few other cases now. 32-bit machines have had a bunch of breaking changes. The most recent one is that the last Debian, I think it was Debian, or was it Ubuntu? Oh, I think it was Ubuntu 2004 shipped with 64-bit time support on 32-bit hosts to fix the year 2038 problem, and that and so suddenly overnight, if you upgraded your base container to Ubuntu 2004, it suddenly changed the syscalls it was using, and again that broke people. So you need to be a bit careful that even if you change the smallest thing, you check, you rescan what the syscalls you're using are. But yeah, you can definitely do that.
Mm-hmm. Okay, I think we've got about 1 minute left or so. I've got one question on my own, and there's another question here. We'll see how it goes. This one might be a quick one. Liam Baker asks, "Is there a SIG security Slack channel?"
Yes, it is. It's called SIG Security on the CNCF Slack.
Cool. And although I think we're at time, one question that I'd really love to ask is in terms of obviously you in hindsight. Hindsight is always 20/20, right? We can look back and we can say what's good and what's not. But in terms of what we've learned, in terms of the way you would go about making these decisions. So, for example, if you was to be faced with the same kind of decisions, obviously different in terms of the actual answers, but the same style of decisions, what have you learned in your approach that would make you more likely get to the right answer?
I mean, it's difficult because the whole environment we're in has changed so much in 5 years. So it's like, and there's so much innovation, and that people are doing things very differently. So that you kind of got to be a bit flexible about things and not lock them in forever. So the more kind of use a generic foundation for things, like with Notary V2, we're putting everything in the registry. It's like, the model of having extensible new types of thing, being able to be stored in the registry is a pattern that has started to be being used because it lets us evolve more things more easily over time, rather than having a special service for signatures. It's like, let's put everything in the generic thing because it's easier to evolve it. So that the more you think, I'm probably going to have to change this again, let's make it generic and general purpose and not too specific, the better. But it's difficult with security things as well, because generic can mean insecure. so you have to be, I think security is hard, so you have to be a bit careful.
Yeah. Awesome. Thank you very much, Justin. And actually, from a personal point of view, I'm very much looking forward to the kind of SNCC Docker collaboration as well, to see how we can help push Docker security forward as well. So really looking forward to that.
Absolutely. It's been great working with you. It's been good.
Excellent. Likewise. Thank you very much.